All right, welcome back. So this is going to be how to solve an equation or a system of equations using three variables using the method of substitution. So you may have already watched the elimination method video. So this is how we would do it using substitution. There are certain times when you would want to choose one or the other. In this case, one of the main things with substitution is that we're looking for an easy way to get a variable by itself. So I'm going to use substitution on this one because I see that this first equation is set up in a way where I can easily solve for x or z. I'm going to solve for x, so I'm going to take this first equation and I'm going to say that 4x equals negative 8z. To get x by itself, I'm just going to divide by 4. So if I do x equals negative 8z divided by 4 is going to be a negative 2z. So I've already solved for x, so I know what x is. And so just like when we were doing substitution with our regular systems of equations, I'm going to just plug x, or the value of x, negative 2z, into a different equation. So I'm going to do that here. So I'm going to take this equation, and I'm going to say that x is equal to negative 2z minus 2y plus z. That's all equal to 0. So if I simplify this, I get negative 6z minus 2y plus z equals 0. And if I simplify that one more time, I get negative 2y minus 5z equals 0. I can do the same thing. I can do the same thing with this equation right here. So I'm going to move that over here. I'm going to do that negative 2x, which is a negative 2z. Is going to, we're just going to continue writing it out, plus y minus z equals negative 1. I simplify this, negative 2 times the negative 2z is a 4z plus y minus z equals negative 1. So I end up with y plus 3z equals negative 1. So now I'm here, I have two equations in two variables, which means I can do basically what I've been doing for the regular systems of equations from here on out. So I'm going to solve for y here. At this point, if you wanted to, you could do elimination or vice versa. So you can switch at any point as long as you're being consistent. So I'm going to solve for y here. So I'm going to do that by subtracting 3z. So y equals negative 3z minus 1. So now I've solved for y. And I'm going to plug it into this equation. So I get negative 2, and I have a negative 3z minus 1, so be careful with all these negatives here, minus 5z equals 0. So I'm going to use the distributive property. Negative 2 times negative 3z is going to be a positive 6z. Negative 2 times negative 1 is going to be a positive 2. And then I'm subtracting 5z, this equals 0. So 6z minus a 5z is just a z, which is really nice for us, plus 2 equals 0. If we get z by itself by subtracting the 2 over, we get z equals negative 2. From here on out, I have z equals negative 2. I'm going to bring this back to this equation because I've already solved for y in terms of z. So I'm going to plug this z value in. So y equals negative 3 times a negative 2 minus 1. If we simplify that, y equals negative 3 times negative 2 is 6, positive 6, minus 1 is 5, so y equals 5. And now, so I've solved for y. I can actually, since I already solved x in terms of z, I can actually just take this z, put it in here. So I get x equals negative 2 times a negative 2. So that x equals a positive 4. Okay? So now we've solved for all three variables, which means we've reached the end of our problem. And so the solution to our system of equations over here is in the form x, y, z, the ordered triple x, y, z, and x is 4, y is 5, and z is negative 2. You can always check to make sure that your answer is correct by plugging each of these values back into one of the original equations and making sure that they are still true. Okay? So this has been a video on how to solve a system of linear equations in three variables using the substitution method.